All right, it's 12 o'clock. I want to welcome everybody to this week's Iowa Learning Farms Conservation Webinar. I'm Matt Helmers at Iowa State University. We're really fortunate today to have a friend and colleague. I think I can call him a friend, Dr. Jeff Strock from the University of Minnesota. I've known Jeff for almost or about 20 years now, and he's been a great collaborator over the years on some different projects, and been fortunate to learn from him. He does a lot of great work at the University of Minnesota, and he's out at Lamberton, Minnesota. So I don't know what they call that, West Central Minnesota. I don't know. Well, I don't know my Minnesota. I know where it's at, but I don't know whether they'd call that Southwest.
We call it Southwest.
Southwest. Okay, the Southwest
Southwest.
Research. Yeah, I should know that. The Southwest Research Outreach Center, right?
Yep, that's great.
So Jeff's going to talk to us today about crop response to excess and deficit water stress. I think pretty timely as we think about things this year. Certainly some deficit water stress, and in some areas some excess water stress early in the year. As always, if you have questions, feel free to type those in the chat box, and I'll get those to Jeff at the end of his talk. But with that, Jeff, the virtual floor is all yours.
Thanks, Matt. And I just want to say a big thank you to everyone down there at Iowa State who's helped coordinate this and asked me to actually present to the Iowa Learning Farms webinar. Really a great honor for me. And I kind of consider, southern Minnesota, northern Iowa, down through that Des Moines lobe, kind of part and parcel of the same sorts of things. We work on the same things. We have similar climates and cropping systems. So again, thanks for the invitation. Glad to present today. So like Matt said, my talk is titled Crop Response to Excess and Deficit Water Stress. Disguised in that title, what I'm really going to be talking about is drainage water recycling. It's something that Matt alluded to in the introduction that we've worked on a couple of bigger projects. We've been trying to get some additional funding for this kind of work. As Matt said, it's fairly timely, at least over the last 3 years, especially the deficit aspect of it. So we'll go ahead and kind of get right started here. My screen, my slides aren't moving, Matt.
Oh gosh.
They were changing on the screen before.
Okay.
Oh, there we go.
Oh, there we
go. Okay, so as Matt said, I'm located in southwestern Minnesota, and we're really kind of interested in thinking about this idea of water stress and these things in response to the finer texture soils that we have, in southern Minnesota and down through that Des Moines lobe into the central part of Iowa. So I went in and I did some work looking at some of the Risk Management Agency data from 1989 to 2018. I've got Iowa, Minnesota, and Wisconsin there, and excess moisture and drought were the two biggest causes of payouts for crop insurance. You can see Iowa and Minnesota right up there neck and neck in the excess moisture payouts. Iowa far exceeding Minnesota and Wisconsin in the drought aspect, but of course we've been experiencing drought for the last 3 years. So this is very timely, I kind of feel like, in terms of a presentation to this group. Another bit of data that I pulled together, this is pulling some of the precipitation data from Ames, Iowa, and Lamberton here. And when you look at it, it kind of looks like a bit of a scatter plot. I didn't put any R-squareds to this because I'm really not trying to make a strong comparison between locations, but what we're looking at is we're looking at a ratio of the precipitation that occurs during the spring and the summer. And the negative slopes that you see moving from left to right are indicative of that our summers are beginning to be, and there's a strong signal from the 90s through the early 2000s here, that the signal indicates that we're getting wetter springs and drier summers. And for corn farmers, for soybean farmers, wet springs make it hard and a little bit challenging to get the crop in the ground at times, and dry summers, especially July and August for the corn and the soybeans, makes it kind of challenging in order to get those top yields that we're trying to achieve. So we put out an experiment. This experiment was done here on some relatively small plots. They are about 1,000 square feet in area. And we did this in southern Minnesota. Initially, we started with just a corn soybean rotation, and we had 3 replications of this project, and we initiated this project on some of our drainage plots. So that figure that you see the bottom there, that represents 24 drainage plots that we have here at Lamberton. So we were able to try to look at some of the water balance, so the drainage out of the system, in addition to precipitation and irrigation into these same plots. For our general agronomic practices, we do a disc rip in the fall, and then we do a field cultivation before planting. The corn and the soybeans are both planted on 30-inch rows, 35,000 seeds per acre for the corn, about 150,000 for the soybeans. And particularly in this case, especially when we're thinking about corn and fertilization, we are doing a spring application of nitrogen. And initially, this project was really only looking at, does adding water in these fine texture soils make a difference in yield? So we weren't looking at trying to make sure we were optimizing nitrogen rates or anything like that. We wanted to make sure that we were adequate with nitrogen, but nitrogen was not one of our treatments. Initially, when we started out this project, we had 3 treatments. We had a rain-fed control. We had a full irrigation to meet the ET demands. So we were using ET as our indicator of how much water to be applying to each one of the plots. And then we had a limited irrigation system which is 50% of the full. Now, as I kind of mentioned earlier, this is a drainage water recycling project. So you see in that bottom left corner, there is a pond, and we actually have a pump and a pond and about a half a mile of 3-inch lay flat hose that supplies water to our site. And we decided to use on-surface drip irrigation as our method of applying water. This might not be the most efficient way for perhaps a farmer to do it. Maybe there's some overhead sprinkler irrigation that might be used, more of a center pivot or linear move system, or maybe a subsurface drip irrigation system. The main reason we use this on-surface drip irrigation is because these are our research plots that we have for drainage, and we didn't want to go in and disturb them and put a lot of additional material in the plots. So we decided just to go with an on-surface drip system where we take it out and put it in every year. Again, we weren't comparing nitrogen rates, nor were we interested in comparing irrigation systems per se, but did adding water in these fine texture soils make a difference in yield? So that's kind of our layout. Up there in the upper right corner there, you can see there's a schematic diagram, and in that lower image, you can see that the drip tapes are every 60 inches when these are on 30-inch rows, so every other row received an irrigation tape. We did quite a lot of measurements out in these plots. I'm not going to represent all of it today, but we'll talk a little bit about the grain yields. I'll show some volumetric water content data that we collected from this PR2 access tube. There we have 6 different depths of water content. We also use some infrared thermometers, some IRTs, as I'll refer to them later, to measure the ambient air temperature and the crop canopy temperature. as a measure of the stress that the crops may have been under, whether they were irrigated or non-irrigated. And then, of course, we have a bunch of weather data that we also collect and drain subsurface drainage, flow volume, and water quality data. But I'm not going to be presenting that data today. This is a figure of the monthly growing season precipitation for 2019 through 2022. Now, this is just a small snapshot of the data that we have for the site. We actually started this project in 2016, and 16, 17, 18, and 19 were all rather wet years. And so essentially very little to no irrigation was put on during that 4-year period. In fact, 2019 was the wettest year that we had recorded during that 4-year period. We had about 42 inches of rainfall here, which normally we're getting about 28. So we had an excess amount of rainfall, and you can see from this figure quite a lot of it occurred during the growing season. 2020 was a rather normal year for us, at least precipitation wise, and then we went into 2021, 2022, and now 2023 as 3 years of drought. So you can see, especially in 21 and 22, June, July were rather dry, and July is really important for us here in Minnesota and you in Iowa for corn reproduction, where the corn is really made in July. And 21 and 22, we were in a strong deficit of precipitation. These little red horizontal lines represent the 30-year average precip that we would get in those normal months. So we were at least 2.5 inches short in July, a little bit more than that, almost 3 inches in June. We were still in a bit of a deficit in August of 2022 and also September of 2022. When we start looking at the supplemental irrigation that we've been adding, 2019, we didn't add any, as I mentioned. 2020, my team could not find the data to be able to put in, but I know we put about 2 inches of water on the corn and the beans that year. It was not a lot. It was about equal in amounts. 2021, just because we had a fairly decent spring, we only ended up putting on 4.2 inches on the corn, 3.2 on the beans. 2022, we added 9.3 and 9 respectively. And so far this year, although I don't have yield data to show you, we've put on 8.7 to the corn and 6.6 inches to the soybeans. One other thing that I want to mention here in particular, which is really an important point since I'm focusing on the irrigation aspect of the data during this presentation, in 17, 18, and 19, even though we were not irrigating during those wet years, it was really important that our subsurface drainage was in those plots, because we were measuring our water contents in the profile, and it was at or near saturation, about 2 feet down in the soil profile during 2019 and 2018 in particular. So without the subsurface drainage in those years, even though we weren't adding water, without the drainage, we would have had probably more depressed yields under our rain-fed conditions than we did, just because that drain tile was helping out remove any of that excess water. So here's some of the corn grain yields. I know this is a really, really busy slide, but the main thing to take a look at is the 2 panels on the right. So the 3-year mean includes 2019, 20, and 21 data. And so during that 3-year period, we had the full, the limited, and the rain-fed. And you can see the full and the limited, there was essentially no difference in statistically in yields. And there was only about a 5 bushel difference there during that 3-year period. And a significant reduction in the yield when we had rain-fed conditions. 2021, we had almost an 80 bushel yield increase from our rain-fed to our full and limited irrigation for corn. The 4-year mean basically is taking a subset of all of this data and just analyzing the limited and the rain-fed data for the corn, since we don't have full irrigation in 22 or 23. And we still had a significant yield increase here in the data, as you can see. When we look at the soybeans, again, it's a rather busy slide. 2019, we had no difference. It was a very wet year, and again, without the tile, we would have been seeing even lower yields than we had. But our 3-year means on the right panel here, there was no difference in yield under the full and limited irrigation for the soybeans. It was exactly the same yield, but it was considerably more than the rain-fed in this particular case. In the 4-year means, again, looking at only the limited over the 4 years and the rain-fed, they're not statistically significant, but they're about 10 bushels. So even though the statistical variability within the plots, there was a lot of variability from plot to plot, which kind of causes this yield difference not to be statistically significant. And a lot of that had to do with the yields last year where they were quite close together. But 10 bushels, if you're a farmer and you're thinking about some of the economics of this, it might make a difference to you. So this, I'm going to spend a little bit of time on this slide just to kind of get everybody tuned into what you're looking at and why this is important. And then we'll actually show some of the data from our research site. So this is the canopy temperature of the corn that we're going to be looking at for our research data. And essentially what we did was we used our infrared thermometers, and we were looking at the air temperatures, the ambient air temperature, and then the crop canopy temperature. And you can imagine that, say, for example, if you or one of your children or a parent or somebody is sick and your temperature goes up, it's an indication that you're under a bit of stress. Well, the crop canopy does the same thing for us, especially under drought conditions or high heat and windy conditions. And so we started looking at our crops that were rain-fed with these infrared thermometers, comparing the canopy temperature and the ambient temperature. And essentially, you would expect that there'd be a somewhat of a flat line or a line that would be above this zero line. Okay, so above the zero line or a flat line indicates that there's going to be some level of stress. If you look at the difference in the temperatures and you get a line that ends up being below the zero line, essentially, that tells you that plant is really not suffering very much stress at all, at least from the irrigation standpoint, which was our treatment here. So this is the data that we've got. This is 2023 data for the corn soybean yields or crop canopy temperatures from the IRTs. This is stress degree day calculation is basically what this is. We do this in degrees C. At the end of the day, it really doesn't matter what the temperature here is. What we're looking at is where's the lines and what's the slope of these lines. So this black line represents the corn in the corn soybean rotation where we have some limited irrigation. And you can see that the slope is pretty steep and it's well below the line, the zero line, which tells us this is not under very much stress. The rain-fed is at a much less slope. It's not above the line in this case, but it is indicating that the difference between these two, that this corn is under a bit of stress. And we plotted this using Julian days. So this is just basically looking at the 1st of June through the current time period. So when we switch gears from looking at the crop canopy to start looking at soil moisture, here's some of the data that we've got. So here's the limited irrigation and the rain-fed condition. This is data from 2023. So we look at what the current conditions are. So if you look at May, June, and July, where we were irrigating, there's really not a lot of difference in the soil moisture under that limited irrigation. And these are by depth. So each one of these bars represents a depth. So the blue up here at the top is the 0 to 4 inches. The orange represents 4 to 8 inches. The gray, 8 to 12. The yellow, 12 to 16. 16 to 24 is the darker blue, and then 24 down to about 36 inches is the dark green. So there's a lot of water in the profile. It's fairly stable by the depths until you get to August, where we're gaining a little bit. So we actually had some rainfall that supplementally added some water to the profile for this limited irrigation for the corn. Soybeans, we really weren't using a whole lot of water. We were irrigating a little bit in June, a little bit in July, again, some here in August when it's really important for the beans. Overall, you see that profile had a bit more moisture, especially early on. The soybeans were small and not really growing all that vigorously until we got into July, and then that big push for yield here in August. But again, fairly uniform for almost all of the depths. We gained a little bit here and there, but generally a nice uniform area. In contrast to those, you look at the rain-fed, the first thing you'll notice is they're not flat all the way across for every month, similar to what we saw for limited irrigation, sort of indicating to us that there's more variability out there. The crop is using water, depleting the water supply, especially at that maximum growth related to putting on yield after the reproductive and during the reproductive period. You can also see that there's a lot more variability by the depths. And by July, we're really starting to run out of water in those surface depths for the corn. Again, August, we got a bit of rain, so things kind of expanded out again where there was more available moisture there. But by late August here, we were really starting to dry out that corn. Soybeans, a bit similar, not a lot happening in May and June. The crop is growing, but a little bit on the slower side. And then July and August, we start to see some reductions in entire water in the profile. We got a little bit more moisture in August. So we were seeing some differences in soil moisture, especially depletion under our rain-fed conditions for this year. So this is these next two slides, I'm going to kind of go through and describe the first set so you kind of get an idea of what you're looking at. Again, a little bit messy, a lot of lines, but once you understand what we're looking at, hopefully it'll help out. You'll get an idea of what's happening on a much more finer time scale. So these graphs represent the limited irrigation on the top, the rain-fed on the top, excuse me, and the limited irrigation on the bottom. When you look at these straight horizontal lines in both graphs, the one that's on the bottom here, this darker blue, and then there's a darker red, those are the same color in each graph. Those represent the field capacity is the top straight line, and the permanent wilting point is the bottom straight line. So when we're looking at the rain-fed condition, you can see early on, this is the timings when we were measuring out there this year. We started out with some depletion of soil moisture during June. We got a little bit more rainfall at the end of June, but then we kind of continued our slow decline. And you can start to see when all of a sudden the corn started using water from different depths. So this orange and blue line represent the surface depth, so the 0 to 4 and the 4 to 8 inches. The gray one represents 8 to 12. So about the middle of June, water started being consumed by that layer. And then it was below the permanent wilting point. Then the corn plant, just kept going deeper, and it started using water deeper in the profile down to about that 18 inches, and then started using water down to that 24 inches. There's still moisture there, but we were starting to get into the danger zone here. And then late in the season with the green line, which is the deepest water in the profile down about 3 feet, you can see later in the season after silking and tasseling where we started using some of that water up. In the limited irrigation, you really don't see that. We do see that we're able to try to keep our water contents between the two lines, between the field capacity and wilting point, at least near the surface. August, we started getting some rain, so things started bumping up. The crop, was somewhat depleted already at this zone in the profile, and it stayed that way for the whole season. And It was fairly stable during the early part of the season, and then started to use a bit of the water down deeper for that corn. We've got the same kind of measurements for soybeans. So here's the soybean data. Again, the top one is rain-fed. You can see we were down below the wilting point fairly quick in the top two depths there, the top 8 inches. We started declining pretty quickly at the end of June, and again with the deeper depths, the lines were shifted compared to the corn, of course, because the corn used water earlier. The soybeans started using water later when they started getting full canopy closure. We were in a bit of peril with the soybeans under rain-fed conditions, except for some rain that we got early in August during about a week and a half period. The data for the limited irrigation, we were staying at or just above the field capacity zone essentially for the whole season, especially up near the surface where all of the action takes place and the vast majority of the root system is. So we were accomplishing what we were trying to achieve here. So one of the things that we wanted to try to do, now keep in mind, as Matt kind of introduced me early on, I'm a soil scientist. I am not an economist. So I did the best I could with some irrigation calculations. The U2U website that's hosted by Purdue University has an irrigation investment calculator. And so I went in and we used the investment calculator. We ended up, when I ran this, I had to run it with a center pivot irrigation. So our costs of subsurface drip irrigation are going to be, a bit different than what it would be for, say, an on-surface drip or a subsurface drip irrigation system. But just kind of for full disclosure, I wasn't able to figure out how to add that data to that irrigation calculator. So we just used the center pivot just as an idea of what could we handle with additional water in terms of projecting whether this is going to be profitable or not. The model that is online is got limited precipitation data, so it's 1980 to 2005, so it does not include any of the more recent data. So that was the database that I was using, again, kind of just for full disclosure. So here is the panel on the right is the corn yields, and so some of the output from the model gives us a dry year, average year, and wet years, and it uses that 1980 to 2005 database as its principal determinant of how many dry years would we have, how many wet years would we have, and how many average years would we have. And then using the yields that we actually took from our yield data from our plots and plugged it into the calculator, it gave us these graphs. So if you look on what they're calling dry land, this is rain-fed. So obviously under dry years and wet years, we have depressed yields. Under average years, which is what we hope we get every year, we can maximize our yields. The model was maximizing out right around 200 bushels, because that was kind of where we were at with the data from our plots. When you looked at adding irrigation in, you see that under the dry years, we can actually bump our yields up from under 180 bushels to well over 220. Our average years, we can maybe gain to 20 bushels, and for our wet years, again, we're probably gaining maybe 20 to 25, 30 bushels maybe. Now, I qualify the wet years and say that every month is not always wet during a wet year, right? So some of the years we have very wet conditions in spring and the summer ends up being dry. But generally speaking, this model was predicting that even under wet conditions for the years of data that we had, that this drainage water recycling supplemental irrigation would be advantageous for the corn. The soybeans is another story. Again, the solid line here across these years, dry years, we're going to have depressed yields clearly under rain-fed dry land conditions. Better yields, about 55 bushels here. Of course, we know we can do better with our irrigation. And then under wet years, Soybeans obviously do not like wet feet, whether it's dry land or rain fed. Irrigating when it's wet for beans is not a good idea, clearly, from this data. But during the dry years, I think we averaged about 74 bushels was our high year, and that's why it's kind of putting this point up there as our maximum. But during average and dry years, we can clearly do very well with adding supplemental water to our soybean plots. So the final graph here that I'm going to show, the system outputs a net present value for this system that we hypothetically put in to model all of this. And what I found really interesting is based on the data that was in the model, 26 years worth of data. During the wet and dry years for the corn soybean rotation, it suggests that it would have been profitable 23 years and not profitable in 3. So again, I'm not an economist. I don't know all of it's a black box to me, but this was encouraging, at least for our attempt to look at supplemental irrigation on soils in southern Minnesota that are typically not irrigated. So to summarize just real quickly, moisture varied by depth and water management in our soil moisture data from our soil water content sensors. The cumulative stress days definitely showed that there was less stress on the irrigated systems compared to the rain-fed systems for corn. The 4-year corn yields exhibited statistically significant differences between rain-fed for corn, but not for soybean, even though it was about 10 bushels for the soybeans. One of the goals that we had when we started this was to really say, does adding some water in these fine texture soils, which already have some really good water holding capacity compared to, say, a sandy soil, would irrigation make a difference to the yields, and would it help reduce stress? And it did both of those things. My very simple economic analysis indicates that it would be a profitable type of a thing to do, in our systems. So, working here in southern Minnesota, again, being part of the Des Moines lobe, I would think that some of the land that you have down there in the Des Moines lobe in Iowa, this would be probably as good or better than what we've seen in Minnesota. You folks down there get a bit longer growing season. It warms up a bit quicker and things like that down there. So I think, Matt, that I got to give some credit here. So this project is funded by the Transforming Drainage Project, the USDA funded project back in 2015. And I think, Matt, that's all I've got. Yep.
All right. Thanks, Jeff. Feel free to get your questions in if you have them. Oh, if you can go back, if you can share your screen again.
Oh, yeah. Sorry.
Yeah.
Sorry.
Yep. So if you need I remember this one from memory. If you need a CCA CEU credit, please email Elena Whitaker, ALENAW, at iastate.edu by 5 o'clock today.
Sorry, Matt. I got to get back up there.
Okay. By 5 o'clock today, and include your name, the name you entered to watch the webinar, and your CCA number. So
there you go.
If you need the CCA credit, please do that. Okay, ALENAW at iastate.edu. And if you can go to the next slide.
Yep.
If folks are willing, there is a voluntary demographic survey that if you're willing to fill out. If you've done one in 2023, no need to do another one, but if not and are able to fill that out, that would be great. You can go to iowalearningfarms.org/survey, or you can scan that QR code. So again, only one survey response is needed for all 2023 webinars. And then to put a plug in for next week's webinar, Nathan Nelson, from another soil scientist, I believe, there
Yep.
from Department of Agronomy at Kansas State University, looking at cover crop impacts on surface runoff, sediment, and phosphorus loss. So, all right. So we do have
Matt,
some
I
questions. Yes.
Matt, I might sign in to listen to that one. I
Uh,
know Nathan gives a
that,
great presentation, so
yeah. I'm glad I'll be able to moderate again. So yeah, I'm excited for that one as well. So I think we'll continue on with another good one. Okay, so we do have a few questions here. The first one is, and this is related to one of your first graphs and your precipitation graph. What
yep.
months did you include as summer?
Well, we looked at the growing season basically. So it was May, June, or no, for yeah, it was May, June, July, August, and September.
Okay, okay.
Yep.
Um, there was a question in your when you said I think conventional corn, was that non-glyphosate tolerant?
No, this would have been glyphosate tolerant.
Okay, okay, great.
Yep.
Um, could you speculate what might happen if you had no-till plots with really good soil structure? How might they perform?
Actually, well, the one thing I would say, and we've observed that's a great question, Matt. So we actually have a long-term tillage trial here at Lamberton. It's been here since 1986, and we were out looking at it the other day, and that corn is still a bit on the green side, whereas the more intensively tilled plots that we have over there are essentially very well on their way to being ready to harvest. So where I'm driving at is where we would look at potentially supplemental irrigation on, say, no-till or maybe even strip till types of situations. It would likely require less water in those plots, and it would probably require more intensive monitoring of some of the soil moisture, because you don't want to over applicate, right? Because if you over applicate, you're just, especially with soybeans, you're opening yourself up to soybean root diseases and other things that are gonna, maybe cause a decline in yields rather than an increase in yields. So I think under those conditions, which we haven't worked on, it'd require a bit more intensive management, but certainly my opinion would be less water, because they're going to hold more water to begin with, just because of that structure that's built up there over time with a lack of tillage.
Okay. The next one, do you have a feel for what the rate of return might be with climatic data that is reflecting the potential for wetter springs and drier summers? And would you feel comfortable putting a number on it?
I don't feel comfortable at all, because I'm not an economist, for one thing. I the what the it's I think about the data from the database from that U2U website, and it was really it didn't specifically drill down to spring and fall, for example, or spring and summer, right? So it was looking at the whole annual average, sort of precipitation behavior to come up with those economic analyses. I think it would take, and it would be possible to do, I suppose, with some of our data, is to take a look at, what might, a simulated, maybe using DSAT or something like that. What might some simulations look like if we forced the model to be, wetter in the spring to some degree and then drier in the summer, and then see what the returns would be yield wise and then economically.
Yeah, and we've started to do some very preliminary modeling. I shouldn't say we. Sam Phillips, which was a master's student that worked with Chris Hay and I, and did some with a little wetter springs and drier summers, and you did see increased yield benefit of that supplemental irrigation. We don't have information on rate of return though, and
Well,
I'm like you, I'm not going to feel comfortable putting a
yeah,
number on
I
it.
won't stick my neck out, but
Yeah,
the other part of it too, Matt, is if you remember back to that one of those early slides where I had the monthly precipitation, any of the audience out there that are farmers, at least up here in Minnesota, the corn's made in July and the beans are made in August. So, if we get that million, or maybe it's a $10 million rain, who knows, on a given year of rainfall during those months, it might make a big difference, even if we're putting on some irrigation water, for example, to the soybeans in June, just to try to avoid stress. So I think that there's probably a lot of really good questions that could be asked when you start drilling down to, maybe not lumping the summer, but maybe drilling down to, like, June and July for corn and July and August for soybeans, and really focusing in on some months as to, if we had a wet month here and a dry month there, what might the yields kind of look like and the returns. Yeah.
Okay. Okay. Did you consider comparing irrigation scheduling with the soil moisture measurements or ET measurements?
Yeah, we really have. And the thing is that I'm personally feeling a little bit like we don't have enough information to really use an irrigation scheduling tool at this point. I've been working with and talking with Vasu Sharma, who's our irrigation specialist up here in Minnesota. And Vasu is really been working intensively in our Central Sands area. And she and I have talked about, what it might look like in these finer texture soils. And she's seen some of the data, and she agrees with me that we can't manage the finer texture soils the same way we would irrigation schedule in the coarse texture soils. And that's why, in one of the years that I didn't disclose, and in all fairness, we were using in 2022, we used the ET-based method to look at our irrigation scheduling. And I very much felt like we over-applied water to the soybeans. I was not happy at the end of the day when I was looking at soil moisture and looking, but I didn't want to uncommit to that method like 3/4 of the way through the season, so we stuck with it. This year, although we're looking at the ET calculations, we're also looking at what's our soil moisture and where are those, top 18 inches of soil at in comparison to our estimates of field capacity and wilting point, so that we're using those two things to try to gauge how much water should we add. Is it really hitting stress or not? So it's more complicated than irrigating the sands for sure.
Okay. So we got a good question here. I'm kind of curious on your perspective on this. And
You're making me nervous.
yeah, no, that's a good one because how do you think this last week of several 100-degree dry, windy days impacted soybean yield in the Midwest? And we might be able to see how much benefit do you think the supplemental irrigation might have given us, or do you think it gave us some benefit?
Well,
I asked that too because we have a site where they applied over the last month about 3 inches of water through supplemental irrigation on a soybean field. So
yeah, well, I think that's a really great question. And I think some of the answer that I'm going to give is it depends. Okay. So we had been irrigating up here, all through August, putting on less than we maybe would have if the drought would have continued that first 2 weeks of August here in Minnesota. So that first 2 weeks of August this year, we had about almost 2 inches of rainfall. We had about 1.8 inches here. And we were watching soil moisture, and it was really carrying us because we were under cloudy, a bit cooler conditions. And then all of a sudden, the heat came back and the winds came back. And so we actually started adding water again about a week ago. And we added somewhere on the order of about an inch last week. And then I came back this week. And when I came back, I said, okay, we're done irrigating, because the vast majority of our soybeans in less than a week's time went from basically R6 to R7. We've got so much color change now. So the real answer to the question, Matt, is that I'm going to think that the water that we applied last week probably is not going to make a huge amount of yield difference, just because we were already hot and we were pushing close to R7. But down in Iowa, if you guys had not hit, that color change like we had, which indicates R7 for us up here, maybe that supplemental irrigation that you would have added even last week would help. reduce some of the stress and maybe add some size to the beans, or at least some
Okay.
mass.
What I would say is, we definitely had a color change over the weekend
Yep.
because
Okay.
I drove on Highway 20 west from central Iowa to Sioux City on Friday night, and then again on Monday afternoon, and it was night and day difference. It was amazing how much color change we got just in 48 hours.
Yeah. Yeah. I mean, so like I say, last week, I'm hopeful, but we have no way in our research trial to look at, did that actual water that we added make a difference?
Okay. So we do have a question. They acknowledge they were a little late in arriving, but can you just go over again how the irrigation was applied?
Yeah, so the irrigation was applied through an on-surface drip irrigation system. We have drip tapes that are applied on the soil surface in our plots. The drip tapes are 60 inches apart, so every other pair of rows. So our corn and beans are in 30-inch centers or 30-inch rows, and so every other row has got a drip tape. We have water that comes from our pond, which is about a half a mile away, and that pond actually receives the drainage water from 320 acres of land, actually. And so any of our spring runoff, early summer rainfalls that initiate tile drainage, that's captured in that pond. And then we go back in, early June, July, August, and then we use that to supplementally irrigate on those plots.
Okay. Can you explain again why there was such a difference in the canopy temperature stress degree day graph?
Yeah, so the huge thing is that, so if you think about this, when you're sick, your temperature goes up, right? So for the corn plants that were under rain-fed conditions, so no supplemental irrigation, that crop canopy temperature went up, and it was getting close to matching or being above the air temperature, mainly because from a physiological standpoint, the corn plant, when it goes under stress, the stomata on the back of the leaves close, and so essentially that's the corn plant's way of sweating or kind of releasing its stress. So when there's not enough available water in the profile, the stomata close because it's going to try to conserve as much water as possible to be able to put into, filling the grain rather than cooling itself to preserve the yield. So the recognition that there was stress because of that higher line is just an indication that the plant leaves are hotter because the stomata close and the water that's available is going into the grain, whereas the opposite is true for the well irrigated plots. So those that slope and that steepness of that line indicate that crop's not really under any stress at all. There's ample water to help cool it. There's also ample water to go into the leaves as well as the corn grain itself. And that's how we kind of interpret that graph.
Okay. Was a question, how often or did rodents damage your drip tape?
Actually, we put out, that's great. That's a great question. So we did not have any problems with our drip tapes until very late in the season, and then we had 3 drip tapes. So we've got let's see, each plot has 9 drip tapes. So we've basically got almost 120 drip tapes out there. 3 of them this year ended up having where rodents chewed on them. And that was in August here. And it was actually the last week that we irrigated. So we really didn't have any problem with that. Now, what I would say to people who are even thinking about using, drip irrigation, the real, like commercial production way to do this is to do subsurface drip irrigation. Put that tape in at 15 to 18 inches deep, depending on if you're doing some sort of tillage, so you're below that tillage zone. Of course, if you're no-till, putting in a drip tape is going to disturb your soil, in those lines that you put it in. But I wouldn't recommend that, on a commercial farm that you use on-surface drip irrigation. It's just what we've been doing again for our research plots so that we don't these are not designated as irrigation plots. There are drainage plots, and we're just happening to be doing the irrigation on top of them. I wouldn't recommend doing on-surface drip, but we haven't had a lot of problems with the rodents.
I think we hopefully got time if you do for maybe a couple more questions.
Oh, sure.
Okay. I know we're getting close on time and some people may have to get onto another meeting, but a couple quickly. Any suggestions, general management guidelines for supplemental irrigation, short of using sensors or measurements in the field?
I guess I'm interpreting that question as to, in terms of managing for water, I would err on the side of caution. And if you have a good setup and you have a good set of gauges, for just knowing how much water you're putting on, I would not add more, especially for the corn and especially the beans, especially in August. I wouldn't add more than maybe an inch of rain or of irrigation water per week. If you had no way to monitor soil moisture, especially under these fine texture soils, you had no way for monitoring. I wouldn't put on more than an inch a week, and that would be under some stressful conditions, some rather hot conditions. If it was more average, I wouldn't put that much on, because you might over wetten the soil where the beans are growing. The other thing though that I think about management wise, Matt, and I was kicking myself this year. We need to go to try to find some funding to probably try to be able to put on fertigation equipment into our system. We haven't done that. We've only had one application in the springtime of the year, and it hasn't been really high. I think the highest we've gone, these are corn soybean plots. The highest nitrogen rate I think we've gone is 155 pounds a N. So it would be nice for us to be able to fertigate, because I noticed this year, it's the first year of the 6 or 7 that we've been doing this. I've noticed that we ran out of nitrogen this year. The corn started getting N deficient about a week and a half, 2 weeks ago. So that would be a management thing where if you're going to put in a system, have it set up for fertigation, and then you can meter out the nutrients as well. Yep. So.
Okay. Kind of the last one. I mean, in your case, you're pulling from a pond. Have you had any issues with unwanted chemicals? And then, I think that, if this were to take off on some of these finer textured soils, we really are looking at the potential to use recycled water rather than groundwater sources, just because we may not have high yielding aquifers there. Yep. So I think it's kind of related in how you see the supplemental irrigation, where it's going to get the water, and then what might be if you've had any issues with that water you've pulled.
Yep. So my first response would be, we have not seen any damage to the corn or the beans from any herbicides, crop protection products that may have leached or run off into our pond. We've done this since 2016, so 7 years. We haven't seen anything. That doesn't mean that it couldn't happen under the right conditions, but we haven't seen anything happen in the last 7 years. From a standpoint of thinking about water supply, here in Minnesota, we're kind of in the same boat as you guys are down there, I think, Matt, where I think the state's a little bit reluctant to look at allowing a lot of punching of more wells, especially in rural areas for homeowners and things of that nature. So this would necessarily be something that would not take away groundwater supplies. The other thought, though, I kind of have is that at least up here in Minnesota, we're talking a lot more about this, and that is surface water storage related to water quality and flooding. And so I kind of feel like there's probably going to be a push in the next number of years for more on-farm storage, more landscape storage of water. which if people are only thinking about it for flood control, they're missing half the opportunity of being able to use it for supplemental irrigation. So, up here in Minnesota, we've got drainage ditches, we've got, sediment basins, the large ones that have been put out there, that we've thought about, can we use ditches if we manage the water in them? Can we use some of that for irrigation purposes? So, it's a tricky thing. You start talking about drainage and then irrigation, and they both can be a bit controversial.
Yeah, that's right. That's exactly right. We got, it's not just one, we got both of them, but,
Exactly.
kind of thinking about, how we can use water and store it on the landscape and maybe use it for some benefit and reduce some downstream nutrient losses in the process.
Yep.
So, all right. Thank you so much, Jeff, for excellent presentation and engaging discussion at the end. I think this may be a topic that we try to bring back some other speakers in the future, because certainly lots of questions at the end. So if you want a CCA CEU, please email Elena Whitaker, ALENAW, by 5 o'clock today with your name, the name you entered to watch the webinar, and your CCA number. Also, tune in next week. Nathan Nelson coming to you from Kansas State. We're doing a tour of all the land-grant universities throughout the, I guess I can't say upper Midwest. What's Kansas? We get into the Great Plains there. So, but with that, Jeff, as always, a pleasure to hear you, and thanks so much for being willing to participate in the Iowa Learning Farms webinars. Wish everyone a good day, and I'll give Jeff the last word.
Thanks, Matt. And again, great pleasure. If anybody has questions or wants to follow up with me, you can email me up here at the University of Minnesota. I'd be happy to answer questions and converse about this. And I also want to my last plug would be you've got another great resource there in Iowa with Matt. Like I say, we've worked on some of these kinds of things before. We're trying to do more work with it. Of course, funding is always an issue. Matt and I, we know about these things, and he'd also be a great resource. So.
All right. Thanks a lot, Jeff. Have a great day.
Yep. Bye.